Hello and welcome, dear viewer. Today I have a small video for you, which will be the first one in a series entitled Side Project Showcase. And what I want to do in that series is simply to show off some of the smaller projects that I've done and that you can use for yourself. They're all publicly available under some sort of open source license, and they're just like small fun things that I've done and that people may be interested in. So today we're talking about the Dava cross compiler. Dava is short for Deutsches Java, which means German Java, and it's a programming language, but it's technically just a modified version of Java. So if you know me, or also if you don't know me, you now know that I program a lot in Java, and I've historically programmed a lot in Java. And so as many people that don't have English as their native language, I've wondered about what Java would look like if it didn't speak English, if the keywords weren't in English, if the standard library wasn't in English, but instead some other language. But in general, most programming languages, of course, are in English. There are some exceptions like Citron, that is multi-language, but in general, most of them are English. And this project is like a whimsical attempt of creating somewhat of a German version of Java. So what it does, what it tells you here in the README, is that all keywords and a couple of standard types are replaced by German equivalents. So yeah, the Deutsches Java is essentially Java speaking German. I'm doing this through a really primitive Python script that replaces all of the Dava keywords by the actual Java equivalent. So this works for very much all of the keywords. We'll go through them later, but I've actually looked at the spec to cover all of them, except that const and goto I don't cover because those don't do anything anymore. They're just reserved for historical reasons. And to run it, I'll show you later, it's really quite simple. So let's look at the file. It's a very short Python file, just 143 lines, and most of them look like this. So what we have is just some basic imports, and this is essentially all of the replacements, which I've used a map for, of course. And this is literally taking a regular expression that matches a keyword and replacing the keyword by the actual proper Java keyword. So public in German means öffentlich, which is what stands here. And we have a lot of them like private, privat, many more. These are the modifiers. Down here we have OOP and data-based stuff. We have the primitive types and the primitive values. We have control flow like if, else, while, do, so on. And down here we have some common Java base class library stuff and some types. So I've actually replaced object, string, integer, and all of the like pseudo primitive types, long, short, float, double, boolean, char. And I've also dealt with the main function as well as print and println and system.out, because that's also what the example, which I'll show you in a minute, uses. As you may know, Java then has these module.info special files that tell the module system what other modules are required and what packages and classes to make publicly available. This is not a tutorial on modules, but that's essentially what it does. And so modules have quite a bunch of additional keywords that aren't used in normal Java code, and I'm actually dealing with all of these as well. So you can use that for actual modules. And there's even a special case that if you name your module info, so the German equivalent, it will actually translate the name into the actual proper German name. So you can even like name your files in a German way. So if we now look at the actual code, it's not a lot. This is just argument parsing, and up here we have the actual stuff which is replacing these patterns with their equivalent, just with a substitution or with a regular expression substitution. So for example, keywords, of course, they have to be at word boundaries, so we're dealing with that. We have some additional matching here with these weird ones. So let's look at an example. Here we have test.dava, which is a simple test file which does some crappy stuff. So you can see we have a public final class test, which extends object and implements comparable of type test. Comparable, for example, is a type that I haven't translated, but we can see that I'm using the package Dava and I'm importing java.util. Then I have my main function with my main operation, which is public static void main, of course, string args. We can see this is a system out println of hello world in German, and it's very German, of course. Then we have some other tests, and down here another private method. So yeah, that's how a normal file looks like, and a module info file looks like this. This is a public module trial that requires java.log, that opens another module, and that supplies test with whatever. So let's run it. All we have to do is call Python 3 with Dava. So this is actually in a folder, so you can just call the folder as though you called a Python file, and if you know about Python, it will then just call the __main__.py file. And you can see that, of course, we need an input argument. We can look at the entire output. So there is only one argument, which is the input, and there is an optional additional argument for the output file. So let's just do Dava test.dava. We should see it compile that almost instantly. Of course, it's not a long file and it's quite fast. So if we look at that, of course, except for the German strings and the German things, you can probably read all of this. It's complaining about dead code, but you can see that even my Java language server recognizes this very well. So this is actually valid Java code, except that I'm trying to assign to a final variable here, which is quite a silly thing to do. But apart from that, it works. Let's look at the module info thing that I talked about. Let's pull up the terminal once more, and let's run this on module info, which should create a module info file. If we look at that, we can see, yes, this compiles properly. Of course, it doesn't work because it's not in the correct folder, but syntax-wise, it's absolutely correct. So this was just a silly example. There's some additional semantics around the module info, and you can choose the output file and all of that stuff. And of course, the ending of the files is .dava. But yeah, that's essentially all. You can look at the things in the GitHub. I'm putting the GitHub links in the description, and this is MIT licensed, so you can do anything that you want. Till next time, goodbye.